Wood procurement and preparation. Sourcing sustainable forestry practices are crucial. Wood is sourced from responsibly managed forests or recycled sources to minimize environmental impact. Debarking. The bark is removed from the logs. Bark contains compounds that can discolor the pulp and interfere with the pulping process. Chipping. Logs are cut into small, uniform wood chips. This size and consistency are essential for efficient cooking in the pulping process. Pulping. This is the core stage where wood is transformed into a fibrous mass. Mechanical pulping. Processed wood chips are ground into pulp using mechanical force, such as grinding stones or refiner discs. Advantages: relatively inexpensive and energy efficient. Disadvantages: produces lower quality pulp with shorter fibers, resulting in weaker paper, primarily used for newsprint and other low-grade papers. Chemical pulping. Process. Wood chips are cooked with chemicals under high temperature and pressure to dissolve lignin, the substance that binds wood fibers together. Kraft process. The most common method, using a mixture of sodium hydroxide, also known as caustic soda, and sodium sulfide, often referred to as white liquor. This process produces strong, high-quality pulp. Sulfite process uses a mixture of sulfur dioxide and other chemicals. It produces pulp suitable for specialty papers. Soda process uses sodium hydroxide alone, primarily used for pulping hardwoods. Semi-chemical pulping. Process combines mechanical and chemical treatments. Wood chips are partially ground and then cooked with chemicals. Advantages: produces pulp with properties between mechanical and chemical pulps. Bleaching. Purpose: to remove residual lignin and other impurities from the pulp, resulting in a brighter, whiter product. Methods: chlorine-based bleaching, traditionally used, but has environmental concerns due to the formation of dioxins. Oxygen delignification, a more environmentally friendly approach, using oxygen to remove lignin. Enzyme-assisted bleaching uses enzymes to break down lignin, reducing the need for harsh chemicals. Hydrogen peroxide bleaching is a common final stage to achieve high brightness. Pulp washing and screening. Washing removes residual cooking chemicals and other impurities from the pulp. This is crucial for subsequent processes and to minimize environmental impact. Screening removes unwanted particles such as knots, shivs, which are uncooked wood chips, and dirt. Screens of various sizes are used to separate particles based on their dimensions. Papermaking. Stock preparation. Pulp is mixed with water to form a dilute slurry. Additives like fillers such as clay and calcium carbonate and sizing agents like starch may be added to enhance paper properties. Sheet formation. The pulp slurry is spread onto a moving wire screen. Water drains through the screen, leaving a mat of fibers. Pressing. The wet sheet passes through a series of press rolls to remove excess water. Drying. The sheet is dried by passing it over heated cylinders. Calendering. The dried sheet is passed through a series of heavy rollers to improve smoothness, density, and gloss. Finishing is the final step in the pulp and paper manufacturing process. Here, the paper is prepared for its final use, ensuring it meets quality standards and specifications. The paper may undergo further finishing processes, such as coating, cutting, and slitting to produce various paper products. These additional steps enhance the paper's properties and tailor it for specific applications. Key considerations. Sustainability. Minimizing environmental impact through responsible sourcing, efficient resource use, and pollution control. Innovation. Developing new technologies to improve efficiency, reduce costs, and enhance product quality. Quality control. Maintaining consistent product quality to meet customer demands.